In this video, we present Sliceplorer, a system for showing multidimensional functions as a series of projections of 1D slices, one for each input parameter. At the top of the interface are controls for selecting which function to examine, as well as the dimensionality if the function is defined over a number of dimensions. The user can also control whether or not they want to show the cluster view and dynamically select the number of slices shown. We evaluated Sliceplorer based on how well one could perform each of 9 tasks derived from Amar, Egan, and Stasko's task taxonomy. We do not demonstrate the correlation task since it is not well supported by our tool. We want to know, given an input, what is the function value at that point. We begin by selecting a value for x1. The user can mouse along the x-axis and find the value of interest. The corresponding slice is highlighted. The user can then proceed to x2 and perform the same action. Finally, the user can read the value of interest off the plot. In the filter task, the user wants to understand what parameter values will cause a function to go above or below a certain value. For example, the user wants to understand when is the function value greater than 8. The user can draw an imaginary line and then simply read off the x-axis when the function is above that line. With the compute derived value task, the user wants to compute various summary statistics about the function under examination. For example, variance, mean, or sensitivity measures. In this example, for the HL parameter, the user can quickly find the mean of the function. It is the dark cluster of lines around the value 80. For the R parameter, the user can see that it shows a periodic wave pattern. From this wave pattern, the user can visually estimate the variance due to parameter R. With the find extremum task, the user wants to find the global maximum and minimum. The user might also want to find the local maxima or minima. These can be read directly off the chart. In many cases, the user wants to try and understand the range of the function, namely, what is the difference between the maximum and minimum value? Since we are showing a global view, the user can simply read the global maximum and minimum value off the chart to determine the range. In the characterize distribution task, the user wants to understand what types of shapes do the manifolds have. For example, with the spherical function, the slices have a consistent bowl-shaped pattern. In comparison, the Ackley function has a higher frequency wave-like pattern to the slices, in addition to an overall bowl-shaped pattern. With find anomalies, we want to know if there are any parts of the function that stand apart from the others. For instance, here the model is predicting that the home price will increase with respect to crime. This is clearly not a desired behavior. In addition, there are 2 slices for which the home price decreases rapidly with increasing index value. These stand out because normally the function does not have much effect from this index parameter. With the cluster task, we want to group sets of similar slices together. Here, we can see that the clustering has divided the function into a set of monotonically decreasing slices, monotonically increasing slices, and bowl-shaped slices. Thank you for watching.